talk about the agenda. So basically, I just have two things. One is the super high level title. You can say interoperability with C. You can also put it with C++, but like I've just put up a quick working version with C. And I think I thought I'll add the use cases at the later point of time, but I'll talk about the use cases first. So that way, I think it's worth understanding that, hey, why it is important for us to do this, then just, hey, I can play around with C along with the code. Third thing is, I mean, whatever we're doing, it's going to be from code, but we'll not be touching about the concepts a lot, but rather in code. And given that most of us are like there is not mix of beginners as well, feel free to shoot questions if you have with respect to the code per se. And we're not using any complex code to understand the concepts as well. Like I'm not using any channels. I'm not doing any Go routines and stuff like that. Those are for a different talk. So that's the agenda. About me, I'm working as a senior software engineer at Elastic. Earlier, I was working at Gojek. And I've worked mostly on, like, I mean, I worked in data engineering, I worked in infrastructure team, Kafka as a service, we were giving it to the whole org. The services I've written in teams, we were using it for like 80K requests per second, like really high level, like highly performance systems. And also like I've used other languages with respect to the general ecosystem, generally lot involved in distributed systems per se, because it's not just to do with the one language, but rather how you build the systems and then how you leverage the tools and ecosystem and stuff like that. Currently in Elasticsearch also, like we use Go a lot of the repositories is open source, but I am majorly focusing on the security aspect of their giving. Like they have observability, they have monitoring and stuff, but security comes in different, like I can share later on. So like that is the starting point, like the way I'm working security, right? Like that was the starting point for me to look at this Go seed kind of things. Like I've always written HTTP services in my last company, but there I never needed the use case for like writing C or using Go along with C. So in this case, right, I'll give you probably two examples to begin with. When I say, okay, I'll give you one more point. So the one which you see in the terminal right now with the yellow mark on it, this is actually a background machine, and this is actually Ubuntu. So even though the code I have it, I've actually synced it, and what we're going to see, it's within Ubuntu. And the concepts also, which I'm sharing, mostly it's based on Linux or like in general Linux concepts, let's say. So there is something called, let's say, like most of us, you would have seen who am I or your user ID, like username, but a lot of times for internal purposes, you would be bothered about, let's say, user ID. I don't know whether you've seen the etc password, but this is basically a holding location of usernames, user ID along with their password, how they've done it. So here I can actually see, you can see that my user ID is actually 1000. And then if I do sudo su, this is actually a different user. I hope the font is visible. Here, similarly, my user ID is actually different. So root is actually 0. Similarly, if I do a different user, ideally, those user would have a different ID. So basically similar to name, underlying what you have is the ID. So here you can see, right, like this is the ID. I think you can also see that in proc self user or something. I'm just looking at a different means to see the same group ID. I forgot the link name, but actually you can see it while running your process. So let's say I have ps aux grep of and and like I'll just do ps aux, and then what you can see here is a lot of times you'll be looking at PID and stuff, but along with it, the user who's running it. So let me just view grep of and let's say we are our syslog, and then as well as spread. Here you can see it's being run as a root. So the lot of data which comes along has user ID rather than this information. So I'll show you something different, which is var log add. Okay, I don't have the audit log here, but like the point is the user ID is one critical thing, but that's not given outside to users easily. And then there is something called real user ID, effective user ID, where that is also critical. But if you have to use those things, I don't have an API right away in, let's say, Golang. And then if I have to look into the code, right, that is actually written in C. So I hope the browser is visible. This is GNU library. And then internally, if you look at any libraries which is written, right, like these are all written in C. So what I was talking about is users groups, and then like forget about setting it, but I'll just show you, right, like just an example. This is the user ID I'm talking about. Like this was the starting point. And obviously, like there is something called like security aspect. Like I'll share the use case also different. So in this point, either you have to write your code completely in Go, or I mean, I can't completely utilize just a Go because I still have to tap into the low level. When I say low level, it's not just for system, but rather Linux level information. I need to be using the C libraries. And this is where the interoperability sort of kicks in. And that's why it's a personal use case for me, but there could be different needs as well. I hope you get the point. Like I also sort of shared the context in user ID because the code will be looking at sort of does that internally with code. So I don't know a way of getting ID directly from here, but there is some proc file. But with C code, you can actually get the user ID. There is much more need for it, like where if you want to set user ID, right? Like those are all not possible with our code. Let's say, hey, if you want to control the forking, control the pipe, and there is a lot of things which goes on. All of that as C libraries, and then that's what we need to like sort of gel with from our Go ecosystem. So the first flow I'll talk about is, hey, from Go, I'll be calling a C library, and then we'll display the information. So this is our first flow, which is, let's say, I have a Go code, and then from there I have a C, and then which does a system call, and then that way we will be able to get the value, but we have a code which does both. Like in this case, most of the people ask, like I think it's called Cgo. Like this is where like this is how we build the application. So that way it's a different way of bundling things than your regular Go build. Any questions on the use case itself, like before I jump in? And don't worry about, let's say, hey, what is this syntax and stuff? Like it's not the issue, but rather we'll just touch upon what it does. And then if you're able to see something, hey, this is getting ID, don't worry about, hey, what is this function? What is this real user ID? Leave that for later. If you are in sync with that, then it's great. If you have any critical questions, do raise your hands. I can't see the chat window, so somebody just stop me as well. So any questions at this point, like just before jumping into the code? I'll assume good to go if nobody jumped in. So the first flow is that, right? Like I'll also show you the Go code first. So in this case, I want to display the user IDs for my application. So like before going into the Go code, I'll try to run the C code itself. So that way we know what we're doing. Yeah, this is where I started. So we were able to see, right? Like Vagrant is user 100, root is actually user 0. So in this code, ignore this. We are not setting the user IDs. What we'll be doing is, hey, get me the process IDs, and then we're just displaying it. Like there's just two information, effective user ID and then real user ID. That's it, nothing else. So I'm just doing this. So let's say I'm just adding a sleep as well. And then I'm doing make build all. I am building everything. Ignore this. I'll share about this as well. And then I'm running this binaries which is generated. Whenever you see .out file, this is actually C output file. So I have also prepended the C. The CAFN is just my directory structure, but this binary is generated for a Go application. So in this case, I have this code, the file name, you can actually look at it in the bottom. This is called UserID change.c. And then I've built an output, and then this is generated as C UserID change.out. So if I run this, you'll be able to see this output. So let me just try to run this. Sorry, I ran the wrong thing. So here you can see main running, and then yeah, because of the sleep, it just too slow. I'll just stop it. Let's just see. Yeah, so you can see, right? This is root, and then you're able to see my user ID is 0. I'm just doing the same thing, and then we should be able to get 100 here. That's it. So this is a program which just displays it, but this is purely written in C. Now let's leverage this, right? Our application is HTTP API or anything, but let's say we are deploying this where we need some use case of getting the information with syscalls. Like when I say syscalls, like stuff like fork, or if you do any operations in bash, like you can enable some audit and stuff like that. Like you'll be able to see a lot of syscalls which is happening. Those are the syscalls, and we'll be able to utilize those things in our Go application itself. So forget about this Go code now. Sorry, C code now. We'll be looking at the same thing, which is user ID change Go. Before going into this, you can just look at this code flow. Hey, main running, get some user ID, and then effective user ID. It's the same thing, but I've just added a prefix Go, so that way you know it's a difference. The big change here is, you can see, is one is import C, and the other thing is I've added some comments, but in this case the comment is not really comments. This is actually some sort of metadata the C Go internally uses, and then these are actually the code which is bundled as part of the our Go final output. So in this case, though we have written the earlier code, if you've noticed, here it's called process UID, but in this case I'm calling get UID. But the implementation or the definition is actually done here. I hope it's visible. If not, I'll just remove the comment for the time being. As you can see, this is a struct, but this struct is not Go struct. This is actually a C struct. If you want to embed multiple things, and I'm including stdio and then other things which should be straightforward. And then I have the similar code where get UID, and then this is calling the same functions, nothing else. So now if I add the comment, and then if I add import C, when I'm generating the build, it actually uses CGO, and then it bundles everything along with us. So I'll just show you the error. Let's say I'm just changing it to a wrong function name. This function name is not really available. And let's try to run it, right? Like I'm just doing a make build all. And then but as you can see, this says, hey, I cannot determine the name for get UIDs. So let's just change it back. And then let's run it again. Here it's successful, right? So all good. Let's try to run. Now the application I should be running is cplay, because I did a Go build. The output is actually the directory name. And then here, if I run cplay, it's actually the same thing. Main running, effective user ID, 1000, real user ID is 1000. Just to be on the same page, I can actually say something different here. The C output is not printed. Like I haven't figured that out yet, but I'll just change this to both IDs are same. So too bad I can't do anything. But let's say I'm just changing it to, I don't know the syntax as well. So I'm doing this live. So if somebody knows C, help me out. Sorry, just a second. Yeah. I'll just open this. Because I'm sharing, it's actually gotten slow, so that's why I'm waiting. So in this case, hopefully, let's say I'm able to change something. This should give me a different information. So let's say just instead of this, I'm changing to int, and then I'm giving this to a different value, 1, 2, 3. And then let's rerun it. Hopefully this should work. If not, um, we'll just revert it back. Well, okay, I think I've done it right. So here you can see, right? I hard coded something, but it's actually a C code. And then when I say C code, this is actually comments, which is getting generated, and then it's sort of I don't know if you've used something like Libardi Kafka or Confluent Kafka Go. Internally, it uses C bindings. And then when you go into actual definitions, right, like publish or consume, you would end up with some C code. This is the code, like, well, LB separate file over there. But the main catch is here, func main is simple. We are using C dot some function. This function should be coming from C. And then this way we have defined C is there is some input C, and above that, there is some comments. It's not really comment, but rather it's a meta information. And then this is the C code which it uses. Here we are using get UUID and then get real user ID. Those are coming from the C internal standard libraries. So that's the first flow. It's simpler. And then we already tapped into the like syscall level, and then we are able to leverage from it. I'll stop here for questions. Any questions so that will clarify, so it's not just a continuous rant or just sharing. So any questions at this point? So straightforward, right? Like you have a Go code. We've written a C. We've seen the same feature in C code, and we've written the same similar functionality, but in comments. And then we are able to use that C function in the Go. So any questions? If you have added in Slido also, like I'll check. If any questions there, let me know. Any questions as of now?
I am seeing first time this CGO. So can you just explain like how to enable? Do you need to set any variable or yeah?
Sure. So
This CGO enabled?
correct. Yes. The way we, I mean, I'll share more context like for others as well, right? If you're running Java and then if you're building something, like you would get jars and your internal dependencies are jars. But when you build Go, you get a single binary. If you've written C, when you try to build it, you will get a single binary output. In this case, it's very similar, but the flags, the env variables matters a lot. Here, I am actually mentioning Go is Linux. So even if you try to run this command from Mac or Windows, the binary you would be getting is something which you can only run on Linux. So these are the ones. This is saying AMD64 or Linux. CGO enabled is the flag which says, hey, this is CGO. Even without this, sometimes I've seen it taken. Ignore this, we haven't seen this part yet. But only for this, the C, it's considered, it uses C and stuff. When I try to cross compile from Mac itself, it internally the libraries are in a different version, because of which I was able to, I was not able to build it. But in this case, I built it inside the Ubuntu itself, so I didn't have issues. But to your question, it's just this, nothing else. And then a regular Go build and directory, and then this is the output we have.
Yeah. So I have another question is that without using C, you are saying from directly Go, we cannot run bash commands?
No,
using only Go?
No, I didn't say you cannot run bash commands. Obviously, there is a means to run bash commands. So let's say, hey, whatever I did, right, like echo something, there is libraries internally. You can say, hey, os.run this command. So I think similarly, you would have run Python, you would have get some interfaces, and then you will be able to give the commands. But what I meant is, let's say I am a root user, but I want to change my user ID, let's say, like there is need for it. Or let's say I want to get the file descriptor, actual file descriptor ID or something like that. those are not something available for us as commands. Like that's what I was saying, right? Like I think like these are much more core to the Linux kernel. And then those are available as a C libraries. You don't need to implement it. If other languages implement it, then it's great. But I don't know whether those languages implemented it. Even in Go, I think there is means to get that. So this is different than just running commands. So whatever command you want to run, you
So
can run it. But this is libraries. I'm talking about C libraries, system level libraries, which I want to use. That's it.
yeah, so let's say if you want to create a new user, you'll
Right.
have to use Sego, right? Um,
Something of
do
that
you
sort.
by any chance know that if you use Python, uh,
Mhm.
again, you need to club it with C, or you will be able to directly, do the same thing using Python?
Similar thing, right? Like I mean, you can run commands, but that doesn't mean that doesn't give you everything, because some are just system level. Like running commands in Bash is very different than accessing
Yeah, I
internal
mean,
calls.
I'm
In Python
basically
also, you
talking
would have to do
system
the same
level,
thing. Yeah, you
same
would have to
thing.
do the same thing. So stuff like, hey, this UUID T, stuff like, let's say, hey, some custom pipe information, some custom fork ID, all of that, like parent ID, those will not be available for us. So I'll show you, right? So I'll just split the T marks, and then I'll do the same thing. Uh, so let's say I'll just edit this sleep for now. Like what I was meant to say is, here you get this information, right? These are something which is core to Linux. Those will not be available for us. That's why we would still have to integrate with C. Even if you're writing other languages, you would have to integrate with the kernel level to make use of this. So yeah, any other questions? Anything else? Like I'll tell much more
There
detail, right?
must be.
Go on. Sorry.
Sorry. So like, I have seen that with Python, for example, there are some libraries like, Fabric or Paramiko. Using them, you can do system level things, especially like, let's say, creating or checking any user ID or process ID.
Right. So that's what I said, right? If any languages implements it, then it's great, because even in Java or any other language, you can create a program, whatever the dependency way it is. But I still would have integrated with kernel level thing, either C Go, what they generated is something with C, right? If they've done it, then it's great. Like you have access. But would you have access to everything? Maybe not. Like they would have implemented in some aspects. The latest, let's say the kernel release would have some functions which is available only in the latest release. If you want to integrate that, you would have to wait for that language to sort of implement it. So I have not used that Python libraries you mentioned. If they expose it, great. But stuff like I mean, we only read the information, but stuff like setting those information, changing those information is much more critical. And I don't know whether they will give access to all other libraries, and then that's not their main objective for those languages. So in that case, I think like it would be some external libraries. So that way, if I'm doing this often, and then if I want this in Python, I would write a library, and then you can reuse that. Great. That's what I'm talking about. But in this case, I directly look at, let's say, this function, and then this is what I want to use, nothing else. So that's why we are doing this. You can do the same in other languages.
Sure.
Uh, yeah. So any other
Uh,
questions? Yeah.
Dinesh, could you talk a little about the safety and the speed of when you are actually trying to call an FFI function, something that is not written in Go, but you're trying to link to a different library? What happens to the safety aspect? I mean, Go does provide you a lot of type safety and all of
Mhm.
that. What happens to
Right.
that? And
Uh,
also, could you talk a little about the performance?
right. So, I mean, I don't have data with respect to prod systems with and saying performance. So I don't know the data. I'll put it bluntly. But obviously, I think this will be much more costlier than how would you expect a Go performance to be. Uh, I think obviously internally it have to deal with multiple conversions, stuff like that, right? So I'm sort of assuming it's costlier. And the memory management doesn't, like, it's unsafe basically. So I mean, I'll show you something. Like, we would have to do something like this piece of code, like what I'm writing. If you have created some struct, right, like some blah, and then you would have to allocate it, you would have to manually create. And the moment you see, right, like I am using unsafe pointer. So the whole static type checking safetiness is gone. And if your internal see the libraries which you're using, the way you're integrating, if those are unsafe, it's obviously unsafe. I think the safety net is only within the limited code, but here I would say it's gone. Like because I was able to see if you're using some custom things, I had to manually allocate it, and then in order to free it, I'm doing c.free unsafe pointer of this block. This is what I would have to do. So that's gone. Performance, I don't have the data. I think here, I think we'll not be writing some concurrent application where we are serving millions of people, but rather it's like, hey, I want to tap into this because like I'm running this as a separate process, like some commands, grep or something like a hedge stop. I think that's what I would see it as. So I don't have data on the performance side. Again, having said that, I don't have all the points. I think that's a different discussion. Like even this, I just started looking at it for some of my use case, and then I'm just exploring, and then I put it out. That answers?
Yes, it does. Thank you very much.
Okay, cool. Yeah, one other thing is, I think like the question would be is, hey, do I always have to be writing C in this way? Because obviously you're missing the C aspects of it, building and things like that, right? Not necessarily. You can do the same thing where you can write regular C code, and then you can import it as a header or a code. So let's just try that. I think I've written something called display IDs. Just like, I hope this is visible. The Zoom is not hiding it. So here you can see this is called display IDs.header. And then as you can see, this is same functionality, but this is a header file. So the commands and everything is still valid. So rather than using makefile, I'll try to use the native thing. So that way, I think it's much more better. So here, so GCC is what I would be using, and then I have display IDs, and then let's say this, yeah, something. Here you can see it's working. So this is a regular header file. So that way, if I make a mistake, it's not a how to put it, like some wrapped up Go error, but rather here I can just literally write C the way I used to do. So let's say, hey, I go here and then I make a mistake. Here it's a regular usage, right? Here it will be visible. And then this is something we can utilize. Though Go gives it, but I'm just saying, I don't know whether it is complete. I don't know whether it's displayed as it is. So we can just literally write C code. We can make use of the editor highlighting everything. And then what you can do is I can go to the this code, which is UserID change. And then I can say import and then display IDs.header. And then along with this, let me also, let's say this is a C function. So that's why I'm preparing it with this. And then I'm calling display IDs. That's it. If you, yeah, that's pretty much it. So ideally this should work. Let's see. Cool. So it says there is an error. Import expected something. Let me just look at this. Display IDs.header. Yeah, it should go here. I hope I've done it right. Let me just check something. Do you import headers in the same way? Like if anybody knows C, you can just mention it.
I think we include it instead of import. We should include it.
Got it. So I think it's sorted. Yeah, it's sorted. So now if I run the same thing, we are also able to see, hey, this was part of the Go. This was included from a C header file, but we were able to say, hey, I can develop on it just as usual, and then you can do this. That's it. So it's not just by comments. You can use C completely, whether it's internal or whether our custom written C files in our Go, and you can leverage it. That's it. So this flow is done. Like we sort of discussed about the questions. So now I'll just move on to the other part, which is, hey, I mean, let's say somebody like me, I have written so much of Go. Now I want to write C function because I want to do some custom authentication for somebody who's logging in. I wouldn't want to go and write everything in C. I don't want to deal with the pain of memory management and everything. Or let's say, hey, I'm using some really cool libraries which is available in Go ecosystem. I would want to leverage it. So that way, the C actually can have a Go dependency, and then this can do maybe, I don't know, HTTP to DB call, anything random, right? So we'll just look at the vice versa of what we saw, right? So for that, let's just do a git code. I initially wanted to get from an API, but assume it's doing that. Like assume here I would be using some HTTP lib. I'll be making an external call, or I can do something like, hey, some complicated image to ASCII and what sort of thing, like anything fun, like which you want to do in Go, right? Let's do that here. And like we'll make this available for a C code. That's it. So do not treat this as a part of the library. I mean, we are not, will not be building a Go binary, but rather what we'll be doing is we'll be building a shared object file, which will be used in C while building it. So the make file sort of have a reference, but I'll still run it separately for our use case. So in this case, what you can see is I am mentioning this Go build, but I'm sort of saying the build mode is C shared. What this will do for us is this will generate headers as well as some SO file if you want to dynamically link it. So ignore all other Go code we have written, but we are just focusing on, let's say, the get code. And then if I run this, what you can see here is the bin would have golib.h, and then it also has golib.so. So let's just remove this just to be sure. And then let me run the same thing again. The header might be available here, but let's see. Yeah, you can see, right? golib.h and golib.so is available. Let's look at the golib.h. And as you can see here, this is something written in Go, but we want it to be included in C. So as you can expect, we are exporting some C, like we are actually will be using some string, but which is defined in Go. So you would have to have a like interoperable types, right? This is what it's doing. So here it says, you know what, goint is actually just signed char. Goint 8 is actually unsigned char. Short is this, and then string is this, and blah blah blah. So this is actually mapping. This is not written by us. So as you can see, created by Go tool C Go, do not edit. You can see, right? And then this is the best part, right? Like this, I mean, I even forgot the extern, but this is the function which we will be able to use from regular C code. That's it. So in this get code, you can do any magic, but this is actually something of C file, like just for, as we imported display IDs.h, this is available for us to use it in Golang. So now let's go to a C file, like I've just put it into a separate file. So that way we know we are not doing anything with a regular Go build. So as you can see here, I have a usual main function, but instead of using our own C function, we are using get code. And this get code is actually coming from this bin golib.h. So I can remove it. Let me try to run make build all. I'll show you the build command in few seconds. So here you can see, I don't know what this Go string is. I don't know what this get code is and everything, right? So here we'll just say add a wrong thing, and then we'll build it. And then here it says, I don't have a declaration for this. Like this is implicit declaration. So at this point we are getting there, right? Like the Go string is not an error. Now we are getting it, and then we are building it. We are able to build it successfully. So now look at it carefully, right? Like I think it's not the build output. What I'll be doing is I'll be running c get quote, which is the file name for this get quote prefixed with c, and then I have a dot out location. I'll go to the make file to show you what's happening. So here I'm doing a build c. So in this case, the get quote is actually built just usual, but as you can see, it's also including a shared object while building it. So if I remove this is as if it can't find the declaration. So my make build all. So you'll say, hey, undefined reference. So this shared binary is important. So that way it's able to figure out the things. So this is working, right? So now you don't need to worry about this. This is also similar, but this is what we have got. And then we'll try to run bin c get code dot out. And then as you can see, hey, this code is generated from Go, right? Let's just change it. And like so that way we know it's clear. So blah Gophers, this code is generated from Go. So I'm just gonna rebuild this. And then I did a bin c code. And you can see, hey, Gophers, this code is generated from Go. So this is the vice versa. And then here, it's just that I don't want to deal with the pain of C, but I want to leverage the Go ecosystem into this. So that way, I don't have, like I can use channels. I can use our internal HTTP libraries. I can use my DB drivers, everything. But C level, I have a interface. So that way, like you're still part of the low-level ecosystem, but you're able to leverage it. Here, obviously, the memory footprint is going to increase because I think if you can see, you can see even though the SO is like just a small bit of code, because our Go runtime is sort of part of this, you can see it's 2.5 MB. So if you're writing some embedded code, I don't know whether you have limitations, but this is obviously bloated in comparison with, let's say, if you're writing a regular C. So if memory is your optimization, then maybe this is not a boon, like a great leverage, but rather if I just want to leverage and if I want to write cool code, like good code, reliable, don't need to manage memory management, everything manually, garbage collection, everything comes for free, right? Like from the Go ecosystem. So in that sense, you're able to leverage this. So that's it. So now we've got it working as well. So in this case, just one thing is, like I forgot to mention, here's very similar, import C, but rather than you're importing it, here exporting it, because this Go file, we are exporting this get code function. If I don't really do this, it will not be able to say, hey, this is part of the header, and that way you will not be able to use it in C files. So this is all it requires. And then this piece of code is regular Go code, nothing else. And I can just go to this, right? I think if I sort of group it, this is a piece where, hey, run C using Go. This will be something like this. And then if I if I do this, this is actually other way around, where run Go using C. This is how it looks like. So here I'm building a C. Then I'm sort of will be including like some headers, and then I have a final output. This is what I'll be running. But running C, in this case, you're using Go, right? So here the Go is the first bit. And then this output, if you could see here, this is being passed in for this C artifact. And then finally, you'll be have something like bin C get code. That is what we are running. So yeah, that's pretty much it. Questions? If there is any questions, shoot. So I'm assuming no questions in that case. So rock solid C interpretation, I'm not aware. Yeah, I think you're right, but I'm not sure. Like, I don't have information to say, hey, this is broken. But I'll give you my use case, right? Uh, I'm sort of exploring something like, hey, when I do authentication in kernel level, so there are some things like PAM, and then let's say so. Here, these are some like, don't worry about PAM or what it is and stuff. These are something which is configured internally so that when you do SSH, right, or when you do a sudo su, these things runs. So, and if I want to do anything custom, so if you can see here, a login. So if you can see here, it says, hey, there are some limits. There is a lot of things which happens. If I want to do something over here, I don't have a choice of using a Java, or I don't have a choice of using a different language, but rather what I have to do is some .so thing. So in this case, you can build a shared object file, or you can build C, which is regular, which you can sort of use it as it is, but still leverage the Go ecosystem where, hey, if I want to call external servers, imagine, right, while like I think we would have used it if you have a login via Google Cloud in console, if you're SSHing into the VM, but rather you have to give something from YubiKey or some Google OAuth token. Those are custom implementations that you can either write it in C, or you can leverage just reuse an existing Golang library or even other languages libraries, build a shared object, and then add your own wrapping code on top of it or custom logic, and then you can tap it to the kernel level stuff. I'm just looking in from the auth perspective, but I think similarly, there'll be so many spaces. I read another use case, which I can tell you, which is, let's say, hey, you're running a game. Obviously, the game is going to maintain a score for every user in some place. What if I am able to figure out that game file, right? I can easily go there and then change my scores over there. Or I can go and change my limitations over there. But what internally the game's applications would do is it internally creates a special user. It internally creates a privileges for that user. So that way, only the game specific user can change its score. That way, I won't be able to touch that file, even though I'm whatever user. And that sort of customs, hey, creating a special user at runtime, whatever the game which is running will convert itself into the user, special user with privileged permissions. So those sort of things, it's again all system level, like be it SSH, be it OAuth, be it VPN, you can tap it to any level. There, I obviously have to write low level code. There, I can leverage any code. Obviously, just like how I did for Go, I think you will be able to do the same for Python or other languages if you're able to build a shared object file. So yeah, that was my use case. Go on if there is any questions. But by the way, come in and share. Like that's all I had to share. Like if there is any specific questions, I'll take it. Again, it's open discussion, right? Like I don't have to be the only speaker. Go on, share what you have, Mohammed, Devdat.
I think one point that I'd like to share is the SIGO or whatever the FFI. When we talk about FFI in Go, while as we talk about FFI in other languages. Now, I'll since this is a Go meetup, I'll be specific about Go here. Whenever we do FFI in Go, given that the Go runtime tracks the memory, it has a GC, it has to do a lot of other things, and it has a runtime which knows everything that is happening in the system. The moment you do an FFI, there is a cost associated to it, which is not trivial. And the reason for people not going so much into SIGO and it being not as performant is because the moment you do a FFI, it's basically all unsafe, like you already said. And the reason is you have to inform the runtime. Hey, runtime dude, what I'm trying to do now is I'm going to call to some other place, which I don't know if it's going to do something with the memory, if it's going to take that memory, free that memory, do whatever with that memory. And that point in time where you inform the runtime that, yeah, you are going to now go to some other place to execute some other piece of code and then come back, is where a little bit of cost is associated. I actually know of a very cool GopherCon 18 talk. Let me dump it in the chat here. People might find it a little interesting if they have the time and the inclination towards seeing, I mean, what and where we can use Cgo. And of course, like, this is a general notion everywhere. For example, even if you talk about libRD Kafka, that had an implementation in C, and people used Cgo to just get this on top of it till they had like a solid Go native implementation. I hope I'm correct here because that was a long time ago.
Yeah. So I think like the Kafka Go implementation is specifically, right, like it's a other way around.
Yeah.
So internally, like if you just say, hey, if I can write everything in Go, it's performant. Of course, it's performant comparison with Java or other languages, but is it performant closer to performance with, let's say, C, just C? Because in C, it's much more low level, right? I think that is where they are leveraging it. That's why they're saying it's much faster. So I understand there is a cost associated with the FFI or the bridging part. Hey, I'm using C in Go, but rather that external function you're calling, that performance is higher if you're writing in something in low level, right? So I think there it's a leverage, but if you purely say, hey, in this Go, it's going to incur a cost for using C or a different language. Yes, that is. But I think for that function, whatever you're using, in this case, it was get code, right? Sorry, it was getting UIDs. Those are the factors, I think, like which will consider while doing it, right? So if there is a library which is available, which is giving me compression ratio of like 20% in, like, let's say 30 millisecond in C, I don't know whether I can achieve that in Go if I write it natively. So that's what I'm talking about.
Of course.
But again,
Yep.
yeah. If other people have done it, they can pitch in.
You mentioned eBPF. Is it a typo?
Yeah.
Because
So I mean, yeah, like similar to Cgo, I think eBPF is a different ecosystem. Like I also got into like aware of it like a while back. If you want to tap into, let's say, hey, what the system is doing, there's a lot of security solutions which is built on top of it. But here, there is, initially it was only available in C, but later on it's available in Golang. But I think as you might be aware, like internally it has a lot of C usages, because that's how they are able to tap in. They can audit stuff like, hey, how many use, like while user SSHing, while user or sudosuing, while they're running commands. So there is a lot of like Linux itself, like audit D is a great thing, like folks,
yeah,
you can check it out.
absolutely.
Yeah, so those things people are able to leverage it, and that's with the mix is what I'm saying. It's not purely like I won't be able to see Go as a just plain thing. Hey, if I write HTTP, okay, then it's Go. Other things I'm not going to think about it. But now I think there's much more wider spectrum which is open for me. Even if in other spaces I'll be able to use it. So yeah.